This section is about toppling and what causes things to fall over. A book on its end is likely to fall over if we push it a little. A book on its back is not. Why? It's all to do with something called centre of mass. And, again, moments. So what is centre of mass? Well, in short, it's what it says it is. The middle of all the bits of mass. Now let's try to define it in a bit more detail. In simple mechanics, we often assume that an object can be represented by a point mass. A mass with the same mass as the object, but infinitely small and located at one coordinate. This works fine for problems involving motion in a straight line, but when the forces on an object all act at different locations on the object, e.g. friction at the bottom, weight in the middle, pushing at the top, then we can end up with an overall moment, a turning force acting on the object that wouldn't show up if we modelled the object as infinitely small point mass. In cases such as these, the centre of mass is useful because it gives us the point where we can say all the weight acts. If we imagine an object being split into lots of individual little masses, then we can define the centre of mass as being the point where the sum of all those masses times the distance of those masses to that point is zero. That is, intuitively, the middle. We can sometimes see where the centre of mass is intuitively or by symmetry. For example, a circle has its centre of mass at its centre. When it's not obvious, we can calculate it. For example, we shall see that the centre of mass of a right-angled triangle is 1/3 of the way up from the sides that form the right angle. When we have a lamina, a 2D shape, we can also find its centre of mass by hanging it freely from one point and drawing a vertical line on it, then doing the same from another point. The intersection of the two lines is the centre of mass. For example, the centre of mass of Great Britain is Dunsop Bridge in Lancashire. So how does this relate to toppling? Well, we use centre of mass to work out if an object will topple over if we push it. Consider a rectangle sitting on a horizontal table. Initially there are two forces. The weight is acting vertically downwards from the centre of mass, right in the middle of the rectangle. The reaction force is also in the middle horizontally, but acts at the contact point, the bottom. Now imagine pushing the rectangle with a horizontal force at the top. If the rectangle doesn't move, then it is still in equilibrium. The reaction force must change its size and line of action so that there is no resultant force or moment. As we increase the pushing force, the reaction must move more and more to the right to ensure equilibrium. Eventually the reaction moves outside of the base of the rectangle, which is an unphysical condition. We call this the point of toppling. Similarly, we say that an object will topple if the line of action of the weight acts outside the base. So, if you're going to try to balance up something unstable, like a rootless tree, keep the overall centre of mass of you plus the tree inside the base. A rigid body will topple if its weight acts outside its base.